Hey guys and gals, welcome back to Scoot's Garage. Today, I want to go over checking battery draw with the Fluke 88 meter. This is going to link into my article on the website itself about why your battery is dying and how to find out what's causing it. So today, what I'm going to do is we're going to hook in line here and we're going to find out how much parasitic draw is getting sucked out of this battery while the car sits. So first thing we want to remember on the Fluke 88 is there's a few different ranges here. There's the 10 amp fused, which is what we're going to go into. Okay, we're reading milliamps, but we're going to stay out of the milliamp scale because if we get a spike, these fuses inside the meter themselves can blow. And these are actually pretty pricey fuses. They're like 10, 12 bucks a piece. So we're always going to go into the amp scale to protect our meter. We'll still get the reading we need. This will take 10 amps fused as opposed to 400 milliamps fused. So if this thing goes over 400 when it spikes, which it will initially, you'll pop that fuse immediately in the meter. The other one is just going to go right into your common ground. And we're just going to go with the regular alligator clips. And we're going to start from there. Okay, so what we're doing is we're disconnecting the negative terminal from the battery. And we're just going to go in line here and read the draw. Okay, on the Fluke 88, we're going to go into the milliamp amp scale. So there we go, we're on DC and we're on milliamps. So what we're going to do now is we're going to hook one clip up to the battery lug itself. We're going to hook the other one just directly to the battery and we're just going to make that connection. Now you'll see when I talk about in the article about the spikes and waiting for things to go to sleep and whatnot, this is a little bit of an older truck. But on the newer stuff, you're going to see a lot more. And that's where the amp hound is going to come into play, which we'll go over later on. So we're just going to hook in. And there we go. You see the spike there. Now what just happened is we hooked power and everything woke up. So it's going to take a few minutes for this truck to kind of put everything back to sleep and get into basically a rest state. So reading this right now, 792, 93 milliamps would be a fairly high draw. Now, the problem is if we don't wait long enough for this truck to go to sleep, we're going to be chasing something that isn't really an issue. So we're going to have to give it a minute, and there it goes. So now we're at 59 milliamps. You clearly see everything just shut down. So this is the point where we could let this meter sit and find out what's going on. Now the Fluke 88 does have an awesome feature, the min-max feature, which will record basically the high, the low, and the average draw. So we could let this thing basically sit overnight if we really had an issue, and we could record exactly what happened. All right. All right, so let's say we had this meter on here, and basically 3,845 milliamps is what we're drawing. So I just kind of simulated a draw on the truck just to kind of show you guys, you know, how we could go about. This is a very basic check. You know, the newer cars especially, this is going to get a little bit tougher to do. I'm just kind of showing you the fundamentals of how to, you know, sometimes you could just catch something pretty quick and simple doing this. You know, the meter doesn't lie. So we have a 3,800 milliamp draw. This battery would definitely be dead in the morning if it, you know, sitting this long with this kind of draw. So now the question is, we have everything hooked up. We know there's a massive draw. We've confirmed it. Like I said, we have all our latches on our doors rolled. You know, nothing is open. The micro switch, you know, glove box light, you know, it could be anything that's staying powered up. So basically what I've done is I've kind of simulated a draw, and we're just going to go through the process. Now what? We have this draw, and what do we do? So basically, you know, your battery's your main feed, and it's feeding everything, and it's running power legs into your fuse box, and here's all your fuses. So the next logical step to isolate the issue would be to start segmenting out the circuits. So I just happen to say, let's pull, you know, start in a row somewhere good, and we'll just pull fuses. We're still at high draw, and we'll just go down the line. I'm not going to do all of them, but there's a 10 amp. Nope, nothing there. So eventually you'll get to the point where you pull these fuses one at a time carefully and give it a minute to see if anything happens to the meter. So let's Let's try that 20 amp buried there. And look at what happened. So now we're down to 64, 65 milliamps. So this fuse clearly is what's supplying the power to our draw. Again, I set this up, so I'm kind of doing this in a cheesy way, which I already know, but it just kind of shows you how to get this done. If I put the fuse back into the slot, let me get my pliers. We're going to see if that draw comes back. And there it is. My meter's already beeping. And it's going right back up to 3,900. So now, in essence, we know that this fuse is powering our draw. So then we could go right here. And it's kind of hard to see, but that's basically the fuse for the stoplights. And I do have the brake pedal depressed just to show you guys. So that would be how you would isolate that draw, is through that fuse. Now, in a more complex situation, we would be printing out wiring schematics, and we would have to find out, you know, if this fuse is causing the draw, what does this fuse feed? We would have to trace the wiring back. The battery is just a central power hub. The battery is sending power legs into your fuse boxes and everywhere else, and your fuse box branches everything out. So the name of the game is find your draw, figure out which fuses, isolate those circuits. Now you're breaking that draw up into segments, and then if it gets, you know, once it gets to that point, we're printing out schematics, we're tracing the wire. Let's say, you know, fuse number 4, this 10 amp powers, you know, the ECM, this, that, the other thing, and then we slowly trace back to those units or those components and just start disconnecting things one at a time until we find out exactly where that draw is. All right, guys. So, you know, that works. The old meter trick, you know, does the job. But here's the thing you might be saying, hey, Scoot, so what are we going to do about a CAN car where we're pulling fuses and it's waking the network up every single time we're pulling fuses? I mean, how long is that going to take, right? You got to pull a fuse, wait for everything to go to sleep, and then try to determine whether or not that's the fuse and then move on to the next one. I mean, can you imagine pulling every one of these separately and waking the car up every time? You'd be here forever. So the way around that is the amp hound. Now what the amp hound allows us to do is we're leaving the battery connected. We know we have our draw, so we're going to go, but the amp hound actually goes in between the fuse and it reads the current getting pulled from the fuse and allows us to see it without disconnecting anything. So in essence, everything is still connected, and all we're doing is reading what that fuse, you know, basically what kind of amperage is flowing through that fuse. So let's give it a shot. We're going to turn on the amp hound. I'm going to try to do this it's a little tough filming and doing it at the same time. I'm going to rest it there and hope it reads. Now, we kind of already know it's this fuse, but let's see what we get. And we get that beep, and when we get that beep, we know there's contact. And there it is. So 0.67. So it's drawing more than half an amp. And that is how we could determine without unplugging anything with the amp hound. Now, you always have to remember to keep your door latches rolled, you know, any other obvious draw, because you want everything to go to sleep. But in essence, that's basically the very, very basic version of checking your draw using a good multimeter. You know, these things aren't too expensive. Check out the website. These things, I mean, they're not expensive, especially, you know, the amp hound is great because you could just sit there and just go across all your fuses real quick and see what's drawn. Unplug the fuse that you see is drawing. You know, if it's an ongoing issue, your battery keeps dying, you put a new one in, you don't know why. This is how you're going to diagnose that stuff and find out what's killing it, what circuit's killing it. Isolate the circuit, and then you can figure out exactly what part of that circuit's drawing. You know, sometimes you do this stuff and you find it and the fuse says, you know, glove box light, you go and that's it, you know, or brake lights are stuck on or something like that. It does tend to get a little bit more complex. Like I said, it's a very basic article, but hopefully it gave you guys some insight on check and draw and finding out what's killing that battery. Thanks for watching.